We are asked to find the resistance of a 24.0 meter long piece of 12.0 gauge copper wire having a 2.053 millimeter diameter. So for this problem, we are going to use the equation resistance, which is a capital R, is equal to resistivity, and that is the little symbol we use for that, multiplied by the length divided by the area. So L over A. And before we start plugging the values into this equation, we are going to have to settle some values over here on the right. So the first thing I want to make note of is that we can notice they have given us a 12.0 gauge copper wire, and this is just telling us the resistivity of the wire. And so the resistivity of this particular type of wire is 1.72 times 10 to the negative 8th ohm meters. And the next thing we have to do is we have to convert this diameter into meters, and then we have to divide it by 2 to get the radius, so we can plug it into the formula for area and then find the area before we before we put the area into the equation. So first of all, 2.053 millimeters is equal to 2.053 times 10 to the negative 3rd meters. The area is equal to pi r squared, so that will be pi times this diameter divided by 2 squared, because the half of the diameter is the radius, so 2.053 times 10 to the negative 3rd divided by 2 squared. And so when we put this into the calculator, we get the area to equal 3.31 times 10 to the negative 6th meter squared. And we are going to use this value for our area and this value for our resistivity. So now that we have gotten those out of the way, we can start plugging in our information to find the resistance of this copper wire that they have given us. So R equals the resistivity 1.72 times 10 to the negative 8th times the length, which they have given us already in meters, so 24.0 meters, divided by the area, which we calculated in meters squared, 3.31 times 10 to the negative 6. And we can just put all of that into the calculator, and we get a value for the resistance of 0.1247 ohms as the resistance of this copper wire.